So as you get done with the stuff today, if you have your phone or your computer up, you can work on quiz 3.1 and 3.2. We're not going to break up into rotations today. We just haven't had enough time. So we'll be stopping and we'll be doing stuff, practicing while we're going. So if you're getting this, go ahead and go on to the practice and do that part of the practice. Okay? So don't waste your time. Make sure you're staying up with me. So quiz 1 and quiz 2. Daily work 3.1 is your POGL that you did last time. Make sure you upload it. I passed back the ones that were handed in because a lot of them weren't finished, and it's a pain in the butt to try and get it on when it's not right there with the rubric. So I'm going to have you submit those, and we'll go with that. Now, let's see. Here we go. This unit is all about electrons and how they interact and where they are and what shape they're going in around the nucleus. And so last time, like I was saying earlier, is you worked on electron configuration POGL. And you worked with these boarding houses and how the people were filling the boarding houses. That's going to hopefully help you understand today's lesson a little bit better if you were able to do that. Today, like I said, we're going to cover orbital notation, electron configuration, and noble gas configuration. So we've got some new words, new vocabulary, and I'm going to be really pounding those new vocabulary with you. I need to make sure that you're staying with me. And if I say outline something, what does outline mean?
Outline.
Go around the outside, right? If I say shade something, what does that mean? Color it in lightly, okay? Don't color it in heavy because we're going to want to be able to see what's underneath this. So we're going to work with your periodic table first up. So if you get your periodic table out and in front of you, we are going to be working with colored pencils to start with. I will let you know when we move to crayons. So with your colored pencils on your table, the first thing that we're going to do is we're going to outline the different areas that tell us metals, nonmetals, and metalloids on the periodic table. You're going to use purple, orange, and green. Purple, orange, and green. I don't care what shade of those you use, but would you outline these areas? While you're outlining these areas and giving yourself a key somehow up high on your periodic table, up by where it says the periodic table, make yourself a key. I'm going to talk to you about the metals, the nonmetals, and the metalloids. When you hear the word metal, how do you know something is a metal? What do you know about metals right now?
Solid.
It's solid. For the most part, that's true. We do have one metal that's a liquid. Does anybody know what it is? Yeah, they used to let you roll it in your hand until they found out, oh, that mercury comes through and sits in your liver. I just said what it was. So mercury. Mercury is also known as quicksilver because it is a liquid silver. Okay, the elements in the first column are also metals, but they're very, very soft. So when he said hard, I was like, some of them are soft. Okay, what else can you tell me about a metal? What color is it usually? Silver, shiny silver. So it's usually silvery white, silvery gray, silvery blue, silvery gold, some kind of silvery color. What else do you know about metals? What do we use them for? We use them for cars to build stuff, okay? And because of that, they are what we call malleable. Do you know what that word means? That's a new vocabulary, malleable. Yes? You can shape it, right? I can pound it. I can shape it. They are also ductile. Anybody know what ductile means? These are two new vocabulary words. Ductile. This one's sort of hard. Ductile means I can pull it and make a wire. So malleable, I can hammer it. Ductile, I can pull it and make wires. Okay, so malleable, pound, ductile, wires. So they are that. Anybody else have any other things that metals, you know about metals right now? I know I use them for cooking. Why would I use them for cooking? Because they what? They don't break, okay. Unless I drop my cast iron, it doesn't break. My cast iron will shatter. Okay, what else? What does it do? What's special about it? Why do I use it for breaking? They're not heat resistant, but they're heat conductive. They'll conduct the heat. So they will conduct heat. They will also conduct electricity. That's why we get lights inside. So metals can conduct electricity, can conduct heat. They're malleable. They're ductile. They're shiny. Okay? All of these are true. So if I know that about metals, which are in the purple up here, what about non-metals? If it's not a metal, what things could I say about something that's not a metal? Okay, it could be a gas, right? Because there's no metals that are gases. That's good. Okay, what else? Look at what's over there. Carbon, nitrogen, oxygen, the noble gases, phosphorus, sulfur, chlorine, selenium, bromine, iodine. This family, or this part of the noble gas, or the nonmetals, are very diverse. I have gases, liquids, solids in there. The thing that's common between them they are insulators, meaning they do not conduct electricity or heat. That's why when they do double pane glass, they usually fill it with a noble gas, because then the heat can't be transferred from the outside to the inside. Okay? That's why we put an insulator around things we don't want heat or electricity to go through. We use a nonmetal. One thing about nonmetals, if I go to hammer it, unlike a metal, it's not malleable. It'll actually powder or shatter. Okay? The middle part, the metalloids, the orangish part there that we're using orange to outline, right? We're outlining these because we're going to be moving really quickly here in a minute. The orange outline, these metalloids are in between. They are semiconductors. They'll semiconduct electricity and heat. They're semi-insulators. Okay? They're semi like a metal and semi like a nonmetal. They're in betweens. Yes?
Is this okay?
No. There's some more over there real fast. Run, run, run. Okay, remember we're outlining. We're not shading. We're outlining. If you've started to shade, go get you a new one. Remember the difference between shading and outlining. Make it quick because I'm going to turn the page here in just a minute. Yes? Yeah, you just want it outlined. You do not want it shaded. We're going to do shading later. Okay, quickly, if you're one of those people that did that, quickly finish. By the way, this bottom part should be purple or blue. The two lines down here at the bottom should be outlined also in your purple or your blue. They're metals. And that last one on the noble gases should be green.
So from TS is purple?
So Tennessee is purple or blue, and Augustin is green. And then the bottom two lines are purple or blue, depending on what you used. I think I said purple. Yes, ma'am. So the purple, these two bottom rows are purple. Tennessee is purple. Aga is green. Yep. So everything on the bottom, basically anything other than Og is metal. That isn't listed on that other side. So quickly do your metalloids. Those of you that screwed up, do the orange in the center, and then just do the green and the purple on each side, because you're going to need. I'm going to turn the page real quick. Those are purple. Okay, so this part just told us if it's metal, nonmetal, or metalloid. And we just outlined. I wonder why I said that at the very first. Do you know the difference between outline and shade? Okay, so our metalloids are a staircase here. If you noticed, they actually go down in a staircase. They start with boron, silicon, arsenic, tellurium, astatine, then they come back up, and we get 2 at this step, 2 at this step, and back up to 1 and 1. Okay, so make sure that you have outlined these, if nothing else. Otherwise, you're going to have to look at a neighbor's, because we're moving forward. In 3. Blue or purple? 2 and 1. This one, what I need you to do is pick 2 colors you have not used. I don't care what 2 colors. Just 2 colors you have not used. Okay? What you're going to do is you're going to get a symbol. I don't care if you use an asterisk, a star, a circle, a triangle, whatever. We're going to just mark the liquids. I'm going to use an asterisk here. And then I'm going to put up here, asterisk is liquid. Then I'm going to pick my second color, whatever it is. And on all the yellow ones up here, do not color them yellow. I'm going to put another one saying triangle, for me, is gas. You can do a star. You can do a circle. You can do whatever. Triangle's taking me a long time, so you might want to pick something else. That is all we're doing here. It's just marking which ones are liquids and which ones are gas at room temperature. That's all we're doing. So there are only 2 liquids at room temperature. One is a metal and one is a nonmetal. The metal is mercury. The nonmetal is bromine. There are several gases at room temperature. If you always remember, the noble gas column is always a gas. And then it's NOFCl, NOFCl, and hydrogen. Okay, NOCl, let's try that again. NOFCl, NOFCl, I guess, and H. These are gases at room temperature. Everything else is a solid at room temperature. This will help us later so that when we know when we're putting chemicals together in a chemical reaction, if something is a solid, liquid, or gas, and what subscript we should give it. So this makes it very simple and easy for us to do what we need to do. Remember that this periodic table is going to become a map for us. We're putting everything we need on it to do the map. Okay, about 15 more seconds on this slide, and then we're going on. Okay, going forward. Now, I need you to grab your green packet because we're not going to have room on our periodic table to write all this. So just for a second, put your periodic table aside. We'll come back to it in just a second. Grab your green packet, open it up to the back of the green page. Back of the first page, that big one. Turn it sideways so it's long ways. And I want you to just really quickly draw a simple periodic table like this, with 6 columns on this side. 4, 5, 6, and 2 down here. They do not have to be perfect. At the top of this, I want you to say periodic families. Then you don't have to write the family in there, but I want you to write alkali metal up the side here. This is tricky doing it sideways on the board. Okay, so you're going to write it up that way. As you write these, I'm going to talk about each of these families. And we'll do more with each of these families later. So the first column, the alkali metal family, each of these families or groups are sort of like gangs, or sort of like families that hang together. And they have similar properties. So the alkali metals, the first column on the left of the periodic table, it hangs together, and they have an extreme dislike towards water. So if you put them in water, they get a little violent. Now, lithium is probably the most calm of the group, and hydrogen's fickle. It goes with that family, and it goes with the fluorine's family. So it flies back and forth, so we really don't consider it part of this group. So, alkali family, it starts with lithium. If you put lithium in water, it will sort of bubble and fuzz around and just sort of react and give us a base. If you put sodium in water, it will get a little bit more aggressive. It'll have a ball of hydrogen that forms around it, and every once in a while you'll get a flare of a yellow flame. And sometimes it'll give you a little pop at the end. If you put a little chunk of potassium in water, it gets a little violent. It hops around, it gives out sparks, it gives you a purple flame, and it gives you pretty good at the end. If you go down to rubidium, if you just take a really small piece of rubidium, smaller than a small pea, and put it in water, it will actually explode. Okay? If you get a tiny, and I do mean tiny, tiny piece, maybe a fourth of that pea of cesium, and put it in a bathtub full of water in a large field, it will explode the bathtub and leave a crater. Okay, you can find a YouTube video on this. It shows all of them. Just say alkali metals with water, and it'll go through and show you all of those. Okay, they are very reactive with water. If you go one column over, those are the alkali.
Sodium. I was going to say sodium.
Yep. The next column is the alkali earth metals, also known as the alkaline earth metals. This also makes bases when they're in water, but they're more calm about it. They just sort of bubble off and they're just fine. Not a big deal.
Batteries.
So you usually use magnesium hydroxide in batteries or calcium hydroxide. They're pretty chill. The next group is the transition metals. That's the lower part on the periodic table. That's 10 across. They have all the different kinds of metals. We use them constantly. Titanium and scandium in baseball bats, and iron and cobalt, nickel and copper and zinc. These are common ones that you probably have known of. And we just call that the transition metal family. They're a big family that hang together. If you go underneath the table, the two rows down beneath the table, the lanthanide series and the actinide series, notice they're not called families there, but they're series because they're so long. These series were hard to separate the individual elements from each other because they were so similar. And when I was in high school, they just found a few of these, and we didn't know what to do with them, just sort of like 113 through 118. But if you noticed over the last, say, 20, 25 years, we've had a boom in technology. We've got cell phones that can do a lot more than they used to, computers that could do a lot more than they used to. That's because of this F block. This bottom two rows, these series, lanthanide and actinide series. Then we get to the boron family, boron's column. That's easy. Boron's column is called boron's family. This is sort of a boring column. Boron, boring. This is the cleaning column. This is boron's used in cleaning, aluminum's used in cooking, gallium, mirrors, indium mirrors, thallium, rat poison, and MRIs. So they're not really exciting. They've got some exciting stuff. Then we get to the carbon family. The carbon family is sort of like the mediator of the periodic table. They can go with either side. They can react with metals or they can react with nonmetals. They're sort of the in-between family, the one that mediates the rest of them. Nitrogen family, they are explosive. Okay, nitrogen family likes to blow things up. This is where we get TNT. This is where we get matches, phosphorus, where we get arsenic and antimony, both that are poisons. Antimony actually is used in eyeliner, so you have to be careful not to get it in your eyes. So there, and then there's bismuth. Bismuth is the mediator of that family because they'll calm your tummy after arsenic and antimony eat it. Then you have oxygen's family. Oxygen is good for us, right? But right underneath it is sulfur, and sulfur's a stinker. That's where you get hydrogen sulfide gas, which you guys know is rotten egg gas. And then selenium and tellurium and polonium all have been used to kill spies in Europe. Then we get to fluorine's column. This is a fancy column. It's not called fluorine's column. It's called the halogens because we use them in halogen lights. So when we use neon lights or we use halogen lights, we're using the halogen family, which starts with fluorine. And then we have the noble gas family that we use to preserve stuff, where they've got the Declaration of Independence in a glass case filled with argon. So lots of different families. You just need to recognize where they are. We're going to be using them throughout the rest of the time. So you now have them in your notes, yes? Okay, going forward. Crayons. On your periodic table, I need you to grab out a blue, a yellow, a red, and a green. I need you to shade, which means what? Color lightly these areas quickly. Color these areas quickly. Make yellow, blue, red, and green. I don't care the shade. So if you like dark blue, just shade it lightly. Quickly shade over everything that you've done. In this area right here, I want you to shade this part of it, whoops, the blue. So half of it I want you to shade blue, and that's to remind you to go down to the blue. Okay? So I'm going to give you about 3 minutes, that's all, 3 minutes to get this shaded, just like what's up on the board. Exact same colors, because I'm going to be saying in the yellow, and if you don't have it shaded yellow, you won't know. So it shades, just like up there. How are we doing?
Pretty good.
Okay. By the way, I will have weekly food packs here right before Friday again. If you are in need, all you have to do is, I'll have them here. You just grab it one and go. Just let me know you got one so I can replace it for next week. You don't have to tell me why. Got about 2 minutes left. Quickly shade. If you are OCD or CDO because you really, really want it a certain way, you can grab another one. CDO is alphabetical order of OCD. Then you can grab another one to do it perfectly when you get home, but at least get it down the way I've got it real fast so you can get it. I will be putting these online so you can look at the video again if you want to for before the test or just to finish stuff that you need. That was an overabundance of stuff. Okay, 1 minute left. Seconds.
Oh, what the?
That's why I said quickly shade it. Just quickly shade the area. You can go back and make it perfect later. It doesn't have to be perfect. Just make sure you've got the area shaded. You know what color is in each area.
Violet red.
Violet red's fine. Doesn't have to be. Just make sure that it doesn't overcolor one of your other colors. Okay, we're going to be adding things to this. So in about 10 more seconds, I'm giving you a little bit more than I should have. 10 more seconds, we're going to come together. You'll need a pencil or a black pencil or pen. Something that will shine through. Okay, here we go. Got it? We're going to number down the side here. 1, 2, 3, 4, 5, 6, 7. We're also going to number here 3, 4, 5, 6. This is going to be 4, and this will be 5. I cannot do 5 sideways. Sorry, guys. Then we're going to come over here 2, 3, 4, 5, 6, 7. Above the yellow area, we're going to put S equals 1 and draw our best shape of a sphere that we can possibly draw. And I am not an artist, so I'll be telling you what I'm drawing before I draw it. So you know what it is. So S equals 1 and your best drawn sphere. If you have to write sphere next to it so you know what it is, do that. Okay, above the green, you're going to put D equals 5. You're going to draw 4 equals a clover leaf. And 1 equals like an infinity sign with something around the center. above the pink, you're going to write P equals 3. And you're going to do the infinity sign, but you're going to try and show that it's like two balloons hooked next to each other. So you've got to do a 3D sort of kind of thing going on. The 4 cloverleaf is also 3D, and this is too, but I'm not going to hold you for that. I'm just, as long as you know it's a cloverleaf. At this point, we're ready to move on and learn more about what we need to know. We've got our map ready, and now we're going to learn how to use it. Oh, nope, one more. Sorry, one more. This bottom section right here should have an F equals 7. And we're not going to worry about the shape because it gets real funky down there. Okay? All right, so grab your green out again. We're going to go talk about it. What we're doing here is we're basically identifying the houses and how many rooms they have. So we have the S house that has just one room, or S rooms are just one. The P's that have 3 rooms that are 6 across. The D's that have 5 rooms that are 10 across. And the F that has 7 rooms that's 14 across. Because remember, you can have 2 in each room, right? And our rooms are actually called orbits. Now, this is how it would normally look. But what happened is we took the F down and put it down below so that we could actually read the symbols. Because if we put the F up in there, the symbols would be teeny and we couldn't read it. But what happens is it fills according to what we call off-bus. So now we're in the green. And we're taking notes now. So if you grab your notes, we're going to go with that for a minute. Don't put away your periodic table. We're still going to be using it. Okay, so as you're filling in your notes, if you want to finish doing your coloring, you can. But make sure you're filling your notes in. So let's review real quick. Underneath this off-bar triad is what it's called. On your notes, it says how many electrons do each orbit hold. I want you to also tell how many orbits are in each shell. So an S sublevel has 1 orbit, but 2 electrons. So I want you to write both of that there under S. 1 orbit, 2 electrons. So halfway down the page, where it says S, put 1 orbit, 2 electrons. All right, look at the P. The P is the pink section on your periodic table. What did I have you write above the P? 3. So how many orbits do you think the P has? 3. Okay, how many places across the P are there? 6. So it can hold 6 electrons. So there's 3 orbits, 6 electrons. Okay, now look at the D, using the same kind of logic. How many orbits? 5, good. How many electrons? Count across the green. 10. Are you seeing a pattern here?
There's twice as many electrons as orbits.
There's twice as many electrons as orbits, because I could put 2 in each room, right? Okay, so what about the F? 7 orbits? 14 electrons, right. 7 orbits, 14 electrons. So I'm basically timesing them by 2. You see that? Because I can put 2 in each room. The number of orbits tells me how many rooms. So that's comparing it to your POGL. Okay, now we're going to go through the reasoning behind the POGL. So it actually talked about these 3 things before as you went through the POGL. The off-ball was the first one. The off-ball basically says, whenever you build, where do you build? Do you start at the top or you start at the bottom? Start at the bottom. So you start at the lowest energy level and you build up, right? Same thing with electrons. We start at the lowest energy level, start filling, and fill to the higher energy level. That's what off-bus says. That's it. Write it in your own words. Off-bus principle. So where do we start building? From the bottom. So the lowest energy levels are filled first, and then we go up to the higher energy levels. So put that in your own words. And we're filling electrons that way. And I'm going to have one of you, I'm just going to point to you, and you're going to get to say these later when we review it. So make sure you write something down. Okay, the next one, there's three basic rules that we need. Off-bus 1. So fill the lowest shell energy level first. The next one's Hund's rule. Now, don't go writing what's up there. Just look at the picture. This was something that you did on your POGL. Just looking at the picture, not reading the words, give me a rule.
The bottom bunk's got to be filled before the top one.
Okay, bottom bunks needs to be filled before the top one. What's another one? Even more than that. Even more than that. What did you have to do in the pink rooms? One person in each room before you went back and put the second person in, right? I want my own room, if possible, right? I want my own room. Hi.
I do too.
Yeah. What can we do to help you?
Amanda Lee here. This is for tomorrow. Thank you.
Okay, so we want our own rooms. So Hun's rule basically says as long as we're on the same level, energy level, and there's an open room, I put one person or one electron in each room first before I go back and start pairing. Okay, put it in your own words. Okay, at the same energy level, if there's an orbit open, I put one electron in each orbit before I can put the second one in. Okay, so if I have a kid and I have 3 rooms, I'm going to fill the first room with the first kid, second room with the second kid, third room with the third kid. But when I have that 4th kid, I have 3 rooms. 1, 2, 3. Somebody's going to have to double up, right?
Same energy level.
Same energy level. I have to put one electron in each orbit first before I can go back and pair it up.
I could only find like 10, 50
We've got to have them somewhere.
more.
And I don't know where they went. The big tall ones?
Yeah.
So check in the main area just on the right-hand side as you go down, and the drawers are. Yes?
I'm confused about where you guys found the information for like previous.
So this was on here. So 1 orbit, 2 electrons. 3 orbits, 1, 2, 3, 4, 5, 6 electrons. 5 orbits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. 7 orbits, 14 across.
Oh wait, so you
So S, P, D, and F. S, P, this was D, and that's F.
how do you know like why wouldn't I do like one electron? Why did I have to do 1 and 2? Like 1 orbit and then 2 electrons. Why did I do that?
Yeah, 1 orbit, because I can have 1 orbit for this. This was definitely defined. 2, because I have 2 across on each row. This one is, okay.
Does it matter if they're plastic or glass?
No, not for that. Okay, so let's go forward. Last rule here. Pauli's exclusion rule. Pauli says, first one in the orbit, first one in the room, I got my own room. That's a plus, right? Then comes the downer. Second person in the room. So one person has to be on the top bunk, one person has to be on the bottom bunk. I have to have opposite spins. For whatever electrons in the same orbit, they've got to be going opposite. I can't have them both on the top bunk or both on the bottom bunk. They've got to be opposite. Okay, so put it in your own words. Put it in your own words. What is Pauli's exclusion principle? They have to be opposite spins. Okay, up here I've shown just the second level on the periodic table. So if you look across the second row on the periodic table, where lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon are on your big periodic table looking across, these are the orbitals they would fill. So the first would be the 2s in the yellow, where lithium and beryllium are. It would be a sphere. And around this sphere, one would be going one way, and the other one would be going the other way. Okay? They'd have to have opposite spins in the same shape. Then we have that dumbbell shape, the balloons, the 2 balloons together. And if you've been in math, you know there's 3 axes. There's the x-axis, the y-axis, and the z-axis coming out at you. Well, those 2 balloons are on the x-axis, the y-axis, and the z-axis coming out at you. Okay? So, those are my orbits. Those are my 3 orbits. Okay? This is how we're going to fill them. So, reviewing really quickly your 3 rules that we're going to be using to fill them. Okay? Ben, what is Pauli's rule? Has to have opposite spin, so up and down. Okay, Tanner. What is Hund's rule?
Like same energy level. There's one electron in each orbit, and so like there's not enough.
Right, so I put one electron in each orbit until they're full, and then I can go back and pair them up. So it doesn't matter if you two want to share the same room. Sorry, everybody gets their own room until I have to pair them up. Okay, Montserrat. I know I said that wrong. Montserrat. Okay. You do off boss. What does off boss say? The first one.
Starting from the bottom of the low energy level and building up.
Right, so we're always going to start at level 1, right? We always got to start with the basement and then build up from that. Okay, so what I've got up here is just an outline. You wouldn't draw this out to start with. You would start and draw it from scratch. But I've got this to help us. So we are going to do helium. Find helium on your periodic table. If you are right-handed, put the periodic table on your left side. If you are left-handed, put the periodic table on your right side, because you're going to be following along with one hand and you're going to be writing with the other hand. Okay? For this first part, though, you're just going to be thinking in your head and writing with me. So stay up here with me because yours is not written down. Okay? So stay up here with me. I wanted to show you how this works. So here I am. I am going to pretend like I'm left-handed. Okay? So here's helium. I've got my finger on helium. I know that I always have to start right here. Okay? I always have to start at ground level. That's level 1. So at level 1 in the S, there is one orbit. So I write this down. Okay? Then I would say, okay, there's one arrow up for hydrogen. So there's going to be a total of 2, and 1 down for helium. I wouldn't have to write any of this other stuff. Okay? That would be it. Okay? Let's try another one. Look at oxygen. Find oxygen. This is why we're doing 4 together before you're writing anything down. So find oxygen. Put your finger on it. Okay? We're going to take our other finger, and you're going to follow along with me as we go. So make it so you can follow, starting with hydrogen with your other finger and coming with me. Okay? So here we go. We're starting again. We have to start with hydrogen. There's how many total arrows that we're going to have? What's our oxygen's number on the periodic table? 8. So we'll have 8 total electrons by the time we get done. We're starting right here with one finger, and we're holding our other finger right here on this oxygen. We're trying to get to it. So we're going through hydrogen. It's on the 1s, so I would have written 1s and put 1 arrow. Then I go across to helium. That's the second arrow in the 1s, because I haven't changed out of the s. I'm coming down to the second row, hitting the s. That's where I would write 2s and write 1 orbit across. So then I put 1 arrow in for lithium, okay? 1 arrow in for beryllium. Then I'm coming across. I'm going to hit the second row, the P. The P has 3, so I put this 3 in, okay? And now I'm going to go across. I'm going to go to boron, carbon, and nitrogen, but I'm still not there. I need 1 more to get to oxygen, so I come back and I go pair that one to oxygen. This wouldn't have been written. Okay? Yes? Okay? The arrows represent the electrons, so they would represent top bunk, lower bunk, if you're doing the POGL.
If you start at hydrogen,
Right.
how are you getting the arrow from helium? Where does that come?
So I start with hydrogen. I put an arrow up for hydrogen. So this would be hydrogen's arrow. This would be helium's arrow. This would be lithium's arrow. This is beryllium's arrow. This is boron, carbon, nitrogen, and that last one is oxygen's arrow.
So the further away the element is from hydrogen, the more arrows.
The more arrows. Yeah, you look at the atomic number, and that's how many you're going to have. So if you count how many arrows here, I have 8 arrows.
And how do you know if they need to be up or down?
Always put the first one in up. The second one comes in down.
And then that one has 2 up. Why is that one down?
2 up.
Yeah, at the end. On the
This one is in 2 different rooms. So these 2 have their own rooms.
Oh.
They're in their own room. Okay, so let's go on to the next one and see if this helps. So silicon's farther down. Okay, it'll be the exact same as oxygen plus some. So let's go up to oxygen. How many total for silicon? How many arrows should we have?
14.
Okay, whatever silicon is, so 14. So I'm going to get to oxygen real quick. That's where oxygen is. So we're now at oxygen. We still need to keep going through here. So I need 2 more arrows in the 2p. Paired. Okay, now I'm coming down to the third row where I hit sodium. The third row in the S, so I put that. S has 1 orbit. So this little squiggly thing really shouldn't be there. It's just 1 orbit. Okay, and I'm going through sodium and magnesium. So I finished those. Now I'm coming over here. 3p. So on the 3p I have 3 orbits. I'm just going to write them up there because this is sort of crazy down here. And I'm going to go through, and how many into the 3p do I need to go? 2. So I put 1 in the first orbit, 1 in the second orbit. Okay, can you see that? Now, in your POGL, it talked about hybridization. That's a big word. Do you remember the hybridization? There was 1 or 2 they talked about hybridizing. Do you remember that the sunny room was just barely below the pink room in the POGL? It was just barely below. What happens is this room right here, it's empty. It's empty, but these guys on about the same level have to share. So what happens is he moves up. And because he moves up, he's able to bond with 4 things. And because he's able to bond with 4 things, he's able to become like a noble gas. If he didn't move up, he couldn't do that. That only happens in carbon's column. Okay, so on the side there, I want you to put carbon's column is special. Carbon's column is special. It stills from the S. Carbon's column is special. It stills from the S. And that just means everybody's going to be the same. Okay, let's go on to iron. Let's see if we can do iron. So find a blank spot on your notes somewhere. You can do it on the front page with the green, whatever. Let's try iron together. And then we've got a couple others we can do together. So iron is in the middle of the green area. Yes? Quickly. Okay, middle of the green. We're always going to start at the top. So let's go back up here, back to the top. Start with the 1s. So we'd put 1s. We'd put a total of 26 electrons. That's it. No, bottom one. Okay, the 1s is going to be my hydrogen, my helium. Done. So I would have written 1s with a line, up arrow, down arrow. Then I go to the second row. I hit lithium. I'm following the numbers on the periodic table. 1, 2, 3. I'm now at 3, lithium. 4 is beryllium. And now I'm going to go across, following the numbers, to boron. Boron is number 5. Boron is in the second row in the P. P has 3 rooms. So I'm going to go 2P, and I'm going to write 3 little dashes above it to represent the 3 rooms. Then I'm going to start filling. Boron, carbon, nitrogen, oxygen, fluorine, neon. So I made it all the way through the P. Now I'm on the third row. I hit the S, so I'm putting these in, and I have 1 room. It doesn't really show it there, so I'll just write it above. I have 1 room. In that, I'm going to fill it with a sodium and a magnesium, and I'm ready to move on. Again, this is sort of weird here, so I'm going to show you the 3P is what I'd hit next, coming across. The third row, I hit the P. I'm going to have 3 rooms in the P, and I'm going to start filling. I'm going to go all the way through that, right? There's 6 across. I'm going to go all the way through because I got to come down here to get to iron. So I'm going to put 6 in the 3P. Then I get to potassium. Potassium is number 19. It's in the 4th row in the S block. S block has 1 orbit. So I go ahead and put 1 in for potassium, 1 in for calcium. I'm now right here. Now I've hit the 3D. Above D it said 5, so I have to have 5 rooms. So I put 3D, I put 5 rooms, And how many into the 3D till I get and include iron? Count across. How many? 6. Good. So going in, 1 in each room, that's 5. 1 more is 6, and I'm done. Okay, now you get to do some from the blank. So we're going to do boron. Yes?
This makes literally like no sense to me. Can you like help me out with this a little bit?
Okay, so let's do boron. This is one in your green. Let's do this one. This is a very simple one. Boron is number what? Number 5. Do you see it? It's in the corner of the pink. Okay, so it's right here. Right? Okay, we're starting at the beginning. So I'm writing it all from scratch, just like you guys are. And it's in your thing. So we are starting right here, which is row 1. We're hitting the S. In the S, there's only 1 room. Okay? We're going through hydrogen first. Hydrogen is my up arrow. Then I'm going to come over here and I'm going to hit helium. He's my down arrow. I'm still in the 1S. Now, I go to number 3. Number 3 is on the second row. It's still in the S. So I'm going to have a new room on the second floor in the S. I'm going to go 1 through lithium, 2 through beryllium. Up, down. I like to use half arrows because it's not as much energy. Okay, now following across, number 4, I go to number 5. Number 5 is on the second row. It's in the P. How many rooms did the P have? 3. P room has 3. Remember, P equals 3 is what we wrote above the pink area. And we only need 1, so we just put an arrow up. I still have to show the empty ones. Okay, now going through cobalt. Let's do another one together. And then if you're getting this, keep going and then go on to practice and do this part in practice. Okay, so cobalt is right here. What number is it? 27. So by the end, we should have 27. By the way, boron was 5, and we had 5 arrows. I'm going to change color because red irritates me. So we're going to do the same thing. We're going to start up at the top at number 1 in for cobalt. So first row in the S, there's 1 room. I'm going to fill it by going through hydrogen and helium. So 1 up and 1 down. Now hit the second row. Making more sense? Second row, I hit the S shell again because it's a yellow. It has 1 room. I'm going through lithium and beryllium. Up arrow, down arrow. Keep going. Then I hit the 2P. See, I'm following it with my finger. This is my finger, by the way, that I'm trailing up here. I hit the 2P. The 2P I know has 3 rooms. I am past that, so I'm going to go through all those 3 rooms. I'm going to fill that up with 6. So 1, 2, 3, 4, 5, 6. I've now hit the 3S. The 3S has 1 room. I'm going to go all the way through it. So sodium, magnesium. Following across, I now hit the 3P. 3P has how many rooms? 3. Look at the number above, or take that area and divide it by 2. I'm going to go all the way through from aluminum to argon. So that's 6 across. So 1, 2, 3, 4, 5, 6. Going on the next row, following the numbers from 18 to 19, from argon to potassium, I land up on the 4th row. I'm now in the S again, and the S has 1 room. Potassium is up, calcium is down. I've now hit the 3D. How many rooms do the D have? 5. 1, 2, 3, 4, 5. So to get to cobalt, how many do I need to go through, including cobalt, to get to cobalt with the 3D? 7. So 1, 2, 3, 4, 5, 6, 7, and done. Okay? Try the next ones on your own. Try.
We have to have up arrows before we can have down.
Right, you have to have 1 up arrow in each room before you put a down arrow.
So you have to fill up all the ones first. Like if it has 5, you have to fill them up with ups
1.
before you put them
Right,
down.
right.
Okay, that makes more sense.
Okay, we're going on to the next one. Yes.
The only thing I'm having trouble with is like
If you are still struggling, stay with me. If you are getting this, try it on your own.
How many down arrows did we have for this one?
1, 2. So in the end, we should have ended up with 27 down arrows. Okay, magnesium is in the yellow area. So if you're still struggling, stay with me. If you're not, keep going on your own. So magnesium, again, we start at the top. We start at the 1. So 1, we're hitting the S first. S has 1 room. Hydrogen's up, helium's down. We've now completed the first one. Going to the second one. Second row, we hit the S block, which is yellow. It has 1 room. Lithium is up, beryllium is down. We're now through it. We come over to here. We hit the 2p. 2p has 3 rooms, 1, 2, 3. And we're going to make it all the way through 6 here because none of these are the one I want. So I'm going to put 6 arrows in. 1, 2, 3, 4, 5, 6. Next row that we hit is the 3s. It has 1 orbit, and we're 1, 2 into it. Done. Are we following me yet? Getting it? Thumbs up if I'm understanding, thumbs down if I'm not, thumbs sideways. I sort of get it, but I'm not quite clear. Okay, so we got some not quite clear. Okay, and some downs. Okay, let's keep going. Try some more together.
wait, we're just doing this until we can like get to like a certain element, like
Right, you just stop when you get to the element you want. Okay, so chlorine, so this one had 12 arrows. This one, chlorine, should have 17. So chlorine's going to be just like magnesium, but I'm going to go past magnesium, right? Everybody agree with that? So we're going to put the same thing that we had for chlorine up, or sorry, magnesium up, and then we're going to add to it to get to chlorine. So this is just magnesium, what we had, so this is up to this point right here. So now we're going to go forward from this point to get to chlorine, which is right here. So we hit the 3rd level in the P. P has 3. We go 1, 2, 3, 4, 5 to get to it. So 1, 2, 3, 4, 5 to get to it. Okay? Now, orbital notation is very important because it tells us exactly where every electron is, exactly the spin every electron has. It also can tell us if an element is magnetic or not, because if to be magnetic, it needs a lot of unshared pairs of electrons, so just electrons with 1 in each orbit. That's how it gets to be magnetic. So if you look at iron, when we did it back here, let's come back, whoops, sorry. It was back here ways. Iron had a whole slew that were just 1 arrow up. And because of that, it was magnetic. So we're going to go forward here. Come on. It's thinking, and then it's going to go forward all at once. Okay, we're stuck for a second. Sorry about that. And I think those two are just the same. Yeah, magnesium and chlorine, I've got it in there twice. Okay, so now, that gets really annoying, especially when you get down to the 111, 112 arrows. I don't like to do them. Nobody likes to do them. That's a lot of arrows, and it gets really annoying. So scientists agreed to shorten it up. So the next part is a shortened version of the orbital notation. You still need to be able to do the orbital notation. Okay, but now you get to learn a shorter way. And that is, like I said, I have to have one hand on the periodic table as I'm going, and the other hand I'm writing down where I'm at. So, here we go. Nitrogen, find nitrogen. It's in the pink area, right there. Okay, so we're going to have 7 of something at the end, and I'll show you what it is in just a minute. So, we start still, ground level off bow, 1s, right? Except this time we're going to use superscripts to tell how many are in the 1s. So in the 1s, we're going to have hydrogen, and helium. There's 2. So we're doing a superscript 2. Then we're going to get the second row. We're going to hit the S, and we're going to go through 2. Then we're going to hit the second row, hit the P, 2, P, and we're going to go how many in?
3.
3. Done. These numbers right here, 2, 2, and 3, all add up to 7. Okay?
Wait, is this
Okay.
another way to do it?
This is, you've got to be able to do both ways, the orbital notation and the electron configuration. Okay, so quickly, let's see what we can do with yttrium. Yttrium's clear down here. Well, it's not clear down there, but it's ways down. We're going to start at the top. Again, I'm going to walk you through this one slower, and then I'm going to have you keep going forward. So if you're getting this, keep going. Okay, so yttrium, we're going to start at 1s. We always start at 1s, and we're going to go 1s, 2. Then we're going to hit the second row. We're going to hit the S, and we're going to go through 2. Then we're going to hit the second row. We're going to hit the P. We're going to go through how many? 6. Good. Then we're going to hit the third row. We're going to hit the S. We're going to go through 2. Then we're going to hit the third row. We're going to hit the P. And we're going to go to how many? 6. Then we're going to hit the fourth row. We're going to hit the S. And we're going to go through how many? 2. Then we're going to hit the third row, the D, and go through how many? 10. Good. Then we're going to hit the fourth row, go through the P, and how many? 6. Then we're going to hit the fifth row, go through the S, and we're going to go through 2. Then we're going to hit the fourth row, hit the D, and go through 1. Yes, you didn't have to write the 1. Okay, so do the next one. See if you can do it faster than I can do. Phosphorus and silver. I'll show you both where they're at. Phosphorus and silver. We're going to go pretty quickly here. So I'll give you a 1-minute head start, and then I'm going to go. So fast as you can. See how fast you can do them. Whoosh. You guys getting this now? Okay, I saw some down hands there, back here. Okay, keep going, keep trying. I'm going to put them up on the board here in a minute, so double check yourself. Are you trying? You getting this? You haven't written anything down. Oh, you're on the noble guess. Okay, so go ahead and do the practice while you're waiting for us to catch up. So if you get this and you filled out the practice part, go to the your practice part. Are you getting this? Okay, so always start it with number 1. So you're going to phosphorus here, right? So I'm going to be your finger. So we're always start here, 1s. So you're going to write 1s. And we're going to go through 2. So you do a superscript 2.
Because it went like
1, 2. And you follow the number. And now I'm at the 2s, so I write 2s. And I go through superscript. Then I hit the 2p. And I go through. And then I hit the 3s.
3s, 2.
And then you hit the 3p, 2, 3. Nope, 3. Stop. Phosphorus is what we're looking for. Okay? So now you try. Yes.
I'm still
So
not
just keep going with it. So 1s, you went 1, 2. 2s, 1, 2. 2p, 1, 2, 3, 4, 5, 6.
So it's
3s, 1, 2. 3p, 1, 2, 3.
Wait, so then it should be 2p
1, 2, 3, 4, 5, 6.
and then 3s,
S, 1, 2.
and then
3p, 1, 2, 3. Done.
Okay, wait.
Oh!
Why does this go back down to 3? Because
Remember off-bus triad? That thing we saw at the very first, this thing right here?
oh, how they put this up here?
Yeah, how they did the zigzag thing.
It's not to me.
This is according to energy level. So the 4S is lower than the 3D, but the 4P is higher than 3D.
Okay.
Okay,
Can I use the restroom real quick?
yeah, run fast. Okay, I'm going to put these up real quick and you double check. Okay, then go on to practice. So double check and make sure you've got it right before you go on. How'd we do?
I got it right.
Thumbs up, I got it. Yes, I understand it. Thumbs down, I didn't get it. Or thumbs sideways, I got one of them. Okay, so those of you with thumbs up, help those with you the thumbs down next to you. I am going to move forward because there's one more thing we need to learn before the end, and we're getting really close to the end of the period. So I'm going to do these really fast. They will be up on the Canvas. So if you want to try them and then check and see, that's great. They'll be up on Canvas. So. Okay, now, this also got really long. I mean, if you get down to the bottom, you just keep going and going and going and going. And what we really need is what's on the most outer shell of any atom to be able to see how it's going to interact with another atom. Okay, it's still important to know how each atom is in there, what shape they're in for other things. But now we're going to learn another thing. So we've so far learned orbital notation, and this is called electron configuration. Now we're going to use noble gas configuration. So this is just an explanation. So watch up here. I need all the eyeballs up here so you understand. So this would be the long electron configuration for gold. Okay? It gets a little cumbersome. It gets really long. So what we do instead is we do the noble gas configuration. Is we play The Price is Right. How many have done that before? How many have watched the show ever before? Okay, what's the premise here on The Price is Right? You have to be closest to without going over, right? So noble gases are on the far right-hand side. Okay, so we're going to pick the noble gas that's closest to without going over gold. Gold is number 79. So what noble gas is close to without going over gold? 79. No, that's over 79. Come on. You just failed. Right? They'd kick you, they'd give you the big gong. Bonk, you're over. 54. 54 is xenon. So I say, gold is like xenon, and I keep going from xenon and say, oh, it has 6s2. It comes down to 4f14, and then I come back up and go 5d9, and I get to gold. Okay? But this is not the end. Because what did I tell you I needed to know from noble gas configuration? I needed to know what electrons were on the outermost shell, because that's what's going to bump into other atoms, and that's what's going to react. So I take this and I look at the shell. That's what that is, that shell. And I rearrange it and say, it's like xenon, but in the 4f it has 14, in the 5d it has 9, and in the 6s it has 2, because that puts the outermost shell on the very end, and I can see what ones are going to react. Okay, let's try it. Aluminum. What is a noble gas without going over aluminum? Aluminum is number 13. Number 10 is what? Neon. So I put neon in brackets and say, okay, keep following from neon. Neon is right here. I'm going to come right here, and I'm going to say it is 3s2. Going through, coming over to aluminum, 3p1. These are both the same level. I do not have to rearrange. Done. Okay, now let's go to the next one. Protactinium is number 89, 91, 91. What noble gas is close to without going over protactinium at 91? Radon. So I'm right here. Radon is capital R, little n. And I start at radon and say, okay, coming right here. I am going to have 7s2 going through. I follow the numbers. That's why I had you color this color, so I remember to go down to lanthanum. And I pick up 4F, and I go through 14. Whoops, nope, sorry. I went to the wrong one. 5F. 5F. And I go, how many? 3. Now, these are not the same numbers, so this does need to be rearranged, and I rearrange it by saying it's like radon. And then what would I put? 5F3, good. And then, at the very end, 7S2, because these are the ones that are going to react. Okay, bismuth. Where's bismuth? 83. What is the closest noble gas without going over 83? Xenon. Xe. Okay, so xenon is right here. I'm trying to get right here. So I start and go right here. I would add to this 6s2. I now, after going through 6s2, I come down to 4f. I go through 14. 4f. 14. Then I come back up and I go through the 5D. 5D10. And then I go into the 6P, how many? 3. This one does have different numbers, so I do need to rearrange it. So it's going to be xenon, which is the lowest level shell. 4F, good. 4F14. Then what? 5D10. Then I just do the S and then the P. P is always left till last if I have it. This is my noble gas configuration. The outermost shell is the S and the P. Okay. Practice. Sulfur. Nickel. See if you can do it fast. You can do it before the bell. Go, go, go.
Just 1 minute.
I know. You can do it before the bell. Go, go, go. You can do it. I have faith. If you don't know where they are, there they are. Yes?
So, how do you get this?
So I look right here, which is the closest one without going over the one I'm trying to get to. So for instance, for sulfur, I want the closest to 16 without going over, so I just go to 10. And I start from 10 and write.
So, where do you usually find it, on this side? Or?
It has to be in this column.
Oh, okay, that makes sense.
Okay, so really quickly, what'd you get here? Neon, right? And then from neon we go 3s2, 3p4. Nickel, you should have argon. 4s2, 3d8, it will change to argon. 3d8, 4s2. Okay, you got practice to do at home. Sorry you didn't have time in class. Happens every once in a while.
Why do we do neon?
Because sulfur's right here, 16, which is closest to without going over 16, 10. So these are my noble gases. I'm choosing from this column.
Wouldn't it be 15 as the highest?
No, has to come from this column. Noble gases only.
Okay, so okay. And I did my my 2.6 quiz on time, but it says it's still not even in there.
This quiz should go in by itself.
Yeah, but it's still not updated.
Oh, not on my DSD. It'll be updated on Canvas. So look at Canvas. I only bring my DSD down once a week, and last week I brought it down on Thursday because I wasn't here Friday. It's just too hard to bring down.
That made no sense at all.
Okay, let me stop it, and then.
I gotta catch the bus.
Okay, I'll be putting it up. And I'll be putting it up so you can re-listen to it, and there'll be other classes too.